Y'all, I can't believe I'm here right now. Y'all are the best. I'm so excited to be here. Give it up for like the conference organizers. This is amazing. So hi, my name is Marchán. I'm also at Maybe Cats of the Internet, and I'm the lead maintainer and architect for the NPM CLI. But I'm not here. Thank you. But I'm not here just to talk about the NPM CLI. I'm kind of going to talk about it. I'm here to talk about a little experiment I've been working on called Tink, which I'm hoping will set a precedent for JavaScript package managers in the future. But before I get into the what, I want to talk a bit about the why. More specifically, I want to talk about what NPM needs to do in order to get JavaScript apps to work. And there's really one big end goal we've had for most of NPM's lifetime. Put a bunch of stuff into your local node modules as fast as possible and have everything consumed from there. Just make that as fast as you can. So that seems pretty straightforward on its own, but what does it really take? For context, I want to talk about the overall problem and what steps we've taken along the way to mitigate the issues we came up with, that came up. Now, the process I'm going to describe is mostly shared between all current package managers. They all do different optimizations and clever things around each step. But they all kind of have to do all of this at some point or another to be compatible with Node. So let's take a look. So this is kind of a high-level overview of what a JavaScript installer needs to do. We all do this to some extent or another, or we have different optimizations around it, but the concerns are ultimately the same. Let's walk quick through these steps. First up is this one. Reading local dependencies if you have any. You'll probably notice this one these days when you have like a no-op install. That is when you run NPM, even though you literally just ran it, and you're sure all your deps are there, and NPM is still taking 5 seconds, and you don't know why. It usually isn't more than a couple seconds, but it's still pretty noticeable. Yarn has an interesting optimization around this, where they just slap a metadata file inside node modules based on the hash of yarn.lock. And if those match, they say fuck it and trust whatever's in node modules, which is a perfectly valid optimization to make. Now, NPM has been a bit stubborn here since we've so far considered that no-up case a fairly rare thing. And if you run NPM, we'll be able to auto-fix any issues with your tree, which we think is important enough to warrant a delay. I don't know. We might go ahead and do what Yarn does at some point anyway, because people just want that sweet, sweet speed up. But you know, in the end, this step tends to be noticeable, but it's not really the biggest delay. But this next one kind of was for a while. Turns out making literally thousands of requests just to get metadata from the registry in order to calculate our tree is a fairly network-intensive operation. And in times before NPM at 5, this was definitely a time hog. So like, what happened? Well, basically, lock files happened. Lock files are super convenient for developers, sure, but they're just a single file cache. Oh my god. What is trying to update right now? Excuse me. They're just a single file cache of the tree calculation step of your package managers. And that's why we love that stuff so much. Once you've built your project up, none of your teammates really need to bother even doing this step until they add or remove a new dependency. This is also why I'm pretty adamant that you should use lock files even for libraries. They just like make life so much easier. Why are you frozen? There we go. Now, this next one has never really been a huge bottleneck on its own, but I still want to mention it because we do put some effort into keeping this step being fast enough. And I want you all to know that this step happens to exist. Long story short, this is what figures out what existing dependencies on disk need to be moved, removed, added, copied, whatever. Since NPM at 3, we also do some calculation to flatten that tree, which is fairly fast now. But you know, how many of you used NPM at 3 when it first came out? There's a handful. It was not the fastest thing on earth. No, it's a lot faster now. Anyway, moving on. This one here. This one is by far the heaviest and slowest of all the install steps, mainly because it's the heaviest on pretty much all relevant resources. Let's dive a little deeper into this one. In the end, we have hundreds of megabytes that need to be transferred over the network. And once we have those, we have to spend a bunch of CPU cycles parsing and gun-zipping the tarbals. And when that's done, we move on to doing tons of heavy disk I/O because we're writing all these files to disk. Literally, all three of the usual suspects are bottlenecks here one way or another. And it all depends on your usage pattern at some particular point in time, so we can just like ultimately optimize everything. Long story short, this is where all the really bad and slow stuff happens. And this has been a huge target of optimization for pretty much all package managers in the JavaScript world. And I assume many other package managers too. So what can we do about this? Well, for one, we can do a bunch of caching of tarbals, and different caching strategies have different trade-offs. NPM stores tarbals themselves, which takes up less disk space, but it means that we have to take the hit of parsing those tarbals every time. Yarn stores them post-extraction, which uses more disk space, but lets them do fast copies of all that data instead of like reparsing the tarbals every time. PNPM here is really interesting because they have an extracted cache, kind of like Yarn. But instead of copying the files, they hard link them into their final destinations. This, kind of surprisingly, isn't really that much faster than copying on like SSDs and stuff. But it's definitely way more space efficient because you pay for each package exactly once across your system. That's pretty cool. And because I can't seem to stop talking about Yarn today, they have this thing called PNP that partially addresses problems in this step. The downside is that tools need to load a plugin, and it mostly works by fussing with the module loader, which can cause some incompatibility. But still, PNP is like really interesting and definitely worth checking out. And I'm sure it's making like a lot of lives easier already. You can tell Mael about it. You can have Mael tell you about it at the next talk. He's great. So there's definitely a lot of work going on to make this particular bit better. And no surprise, it's the most expensive bit. I'll get back to this soon and what else we can do about it. But for now, let's wrap this walkthrough. So we do all the downloading and extracting, and then we have to scan through all the packages we just installed and execute any run scripts. This isn't usually the biggest step, since there's usually only a couple of run scripts that run, and most of them aren't that slow. But this still becomes noticeable on some unfortunate projects. NPM doesn't do this, but some package managers actually parallelize this step at great risk and complexity, but they pull it off. And it does make things a lot faster if you have heavy stuff to build, like Oniguruma, which takes forever. I think we're better off with a solution with something like Node prejep, or have actual like pre-built binary somewhere on the registry. But that's what we got right now. Anyway, what you should take away here, though, is that in the end, Node modules is massive, and also where dreams go to die. Now, the fact is that great Node modules, while a great abstraction, has caused everyone massive headaches in usability and time wasted and disk space abused. There's a lot to agree with on this front, with like Ryan's talk about Node regrets here at this conference. What are you doing, microphone? Please calm down. But what do we actually do about it, right? It's easy to complain about and talk about how bad an idea it is, but I still think the good outweighs the bad. Like, isolated dependencies are really good. Like, having each individual project be able to manage its own dependencies is fantastic. Being safe from dependency hell is really good. The fact that we automatically nest things, that's great. And we have kind of 900,000 packages out there that some of you might think that some of them are crappy, but most of them are pretty useful. At least a big enough percentage of them are useful that we want to keep that. We want to have that compatibility. So, and it's really on us, both package manager developers as well as the larger community, to do what we can to make the most of this, right? I, of course, have my own ideas about this, and I kind of hinted at what that was already. What I think we should do at this point is move package management itself directly into the runtime instead of an external utility. And that is what Tink is really about in the end. But what does this mean, and what can we actually do with it once we've done that? So this is what I'm talking about. You literally stop invoking Node yourself, and you use this new tool called Tink instead. It has a subcommand called shell that wraps Node and adds a few patches to FS to make it work its magic. What magic? Well, virtual Node modules. The big idea is that if we control the runtime, we control what happens when someone tries to read from Node modules. And once we can do that at the runtime level, all sorts of things start happening. It means that we can get rid of all these copies of Node modules without changing the module loader or the expected APIs from packages. As far as any packages are concerned, they're accessing the file system the same way they usually do. And this means it's compatible with little details like __dir name, like fsread file sync for reading configuration files, and literally all of that. It just works out of the box. Even spawn sync, even spawn works. But if we're not in Node modules, where are the files? Well, instead of copying them, we keep them all in a single global cache, a lot like PNPM does, except we deduplicate every single file at the hash level. That means if you have 5 different versions of the same package, you'll only ever have new copies for the files that actually changed. Storing by hash can also make reads very, very fast for us. But hey, we can do more. Since we control the runtime, why don't we just automatically fetch dependencies for you as you need them? Why don't we skip downloading dependencies you're not using in your current work? Tink is actually able to block on reads that failed from the local cache and, in line, fetch any packages you haven't downloaded yet. It makes Node work a bit more like a browser in that front. And yes, before you say anything, there's a -- production flag to disable this if you want to and make sure we're not doing any random requests and dependencies in production, et cetera. And of course, this means you don't do npm install anymore. You don't do npm install and wait for things ever again. There we go. Yeah, go for it. Go for it. All you actually do is you do tink add, tink remove to add and remove individual dependencies. And you otherwise don't worry about having an install step anymore. It all just gets done automatically by Tink as needed. It means if your coworker pushed something and you pulled it, you just run it. And it just kind of works. And you don't have to worry about it. There's no conflicts to worry about or new installs. Now, you might be concerned about this, by the way. Patching FS itself sounds really risky, right? But I'm not that worried. This is literally the same approach that ELECTRON has taken, and they're very successful at it. We can also learn from their journey, so I believe this will all work out in the end. In fact, some of the code to do this in Tink comes directly from ELECTRON, and I modified it further. But wait, there's more. There's other things that Tink allows us to do now that we have runtime control. Tink has TypeScript, ESM, WASM, and JSX support out of the box. Yeah, right? 63%? Are you kidding me? How did y'all multiply? It was like 40% last year. It also runs a very cheap checksum on every single file it loads from the global cache. So you know that what you're getting out of the cache, what you're getting into your node, is passing a hash check, a checksum for every single load, which is fantastic. It's super secure. And if it turns out you ran the Tink shell and there's a missing dependency, well, and if a single file was corrupted in your cache even, Tink will just download and install it for you and fix your dependencies automatically. You can turn this behavior off in production, but when you're actually developing, it's super handy. And finally, my favorite part, all of this comes out of the box without the need to configure or install anything besides Tink itself. And I want to emphasize this. All of this comes without the need for any sort of loader. Webpack, it works. Test frameworks like Tap and Jest, they'll work too. And all of this without any kind of loader or extra flag or anything. You install and run things with Tink, and that's literally all you need to do. Now, let's do a brief tour of the tool itself to give you kind of an idea of what I'm actually talking about. This here is the core feature of the entire tool. Just about everything I've talked about so far is available through this one command. Remember, you don't need to do npm install anymore. That step is gone. All you do is run Tink shell, and all your dependencies are fetched and extracted as needed by the runtime as it executes your app. This also works in the interactive shell. So it just blocks and waits for things, and then you fetch your dependencies, and it just kind of goes. I know I talked about performance a lot before, but a really strong guiding light for me when working on npm and Tink has been the idea of simplifying workflows. I want you to have to install and remember as little as possible in order to be productive. I know that that's a big problem in JavaScript these days, where you just install, it feels like you install half of NPM just to get started. The ability to just start running and having the runtime take care of this is super important to me in order to achieve the workflow I think y'all should have in your day-to-day. In the end, I want the package manager to disappear and not be something you have to think about. That's very important. So how many of you are familiar with NPX here? Show of hands. Yeah, NPX, go. Anyway, Tink exec is NPX. This is NPX for Tink. For the rest of you who don't know what NPX is, it is a tool that's bundled with NPM itself. And one of the things it lets you do is execute local binaries, as well as like temporary installations. For example, if you install jest as a dev dependency instead of globally, you can use npx jest to invoke your dev dependency without needing to install it globally. You don't even need to configure a run script for it. You don't need to have like npm run test or anything like that. Now, running your local bins through Tink exec means that we can apply the same logic to pre-install anything necessary for your binary that Tink shell does for scripts. But what if you don't want to slow down your app with package management stuff? That's where Tink prepare comes in. This command goes ahead and does all the cache warming beforehand and runs and installs binaries and the like for you. So when you run Tink shell, it just works as fast as if you'd done an npm install or something beforehand. You could argue that this is the npm install of Tink, but it's important to note that it's very much an optional step, and it might not even speed things up at all. Or it might even make absolute time pass slower. Like on CI, you may as well take the runtime hit of fetching dependencies. But what if you want to have an actual node modules anyway? Like, what if you want to like inspect and use other tools or your editor which doesn't understand Tink yet or whatever? In this case, there's a nice command called unwind that actually does a full extraction into node modules. So you can use your editor, non.js build tools, pretty much anything in the usual way. This is basically an npm install, but there's a slight difference that I'll go into next. So what if you want to debug a specific dependency instead of installing a full tree? Well, then you can do Tink unwind and give it a dependency, and it'll only unwind that one dependency, plus its dependencies. That will let you patch things however you want, debug it, etc. And this is something I want to emphasize. Because of the way Tink works, anything inside node modules itself takes precedence over the virtual version. And in fact, if you use fs.write file or a similar API, Tink will actually create a physical file for you in node modules, which helps immensely with like compatibility. Like if you have something that randomly writes to node modules, that'll just work. We'll just put a file there for you. Don't worry too much about it. Now, this command is also done automatically at the individual package level for any dependencies that use install scripts, precisely to preserve compatibility, because Node.js doesn't really understand Node itself, so we actually extract it, but it's very few extractions. So since the closest thing to npm install only builds existing dependencies, how do we add and remove dependencies besides adding them back in JSON? Enter the classic trio: add, remove, and update. Great, fancy. They do basically what it says on the tin. You give them the packages you add and remove. They do it and write out in the unu package.json and package.log.json. Oh, and by the way, all three of these become fully interactive if you give them no arguments. That means you'll be able to search interactively for new dependencies and pick them from a menu, ditto for removing and updating. Yeah, that's epic. Yeah! Interactive menus! Very exciting. So the last command I'm going to introduce is this Tink check utility. The really cool thing about this is that it's a one-stop shop for all your verification and testing. The most noteworthy thing here is that it's going to run your TypeScript type checks out of the box without needing to install TypeScript as a dev dependency. If you do install it as a dev dependency, we'll use that version of it, but it'll still run it for you. But isn't it nice to just be able to like go into a project and type check the TypeScript out of the box, lint it? It's really nice. At this point, some of you might wonder if I've been doing too much Rust and Cargo lately, and I think you'd be right. But this isn't a Rust conference, so let's move on. Rust is great. So OK, so where do we go from here? Well, first, we have to wrap up the prototype because it's That's all it is right now, a proof of concept. That should happen soon enough. The next step is exciting. We want to build an open RFC-based team that includes more outside contributors than we usually had in the NPM CLI project. This will allow us to really hash out Tink and take it where it needs to go together. The RFC process will ensure there's a community-based approach to growth and development, and it means that you can make a difference by participating. Once that's all set, we are turning Tink into NPM 8. That means that in the future, when you upgrade Node, what used to be called Tink will be available out of the box as NPM, just like current versions of NPM are. You can still use NPM as you usually do, but if you want to opt into this new workflow, the tool will be there for you. It'll also integrate with NPX, meaning all your NPX commands will run that much faster. Finally, once NPM at 8 is shipped, and fixed, it's a matter of integrating it into Node itself, and I look forward to working with the folks over there to make this happen. I know it's a big step to be like hacking FS itself, so this kind of requires a bit of API work on both ends possibly, but I'm sure we can make it happen. I totally left the TK in my notes, by the way. Anyway, and there's one more thing. We are planning to release at some point in the future a new package fetching API in the main NPM registry. This is exciting because combined with Tink or something similar, there's a good number of advantages. And this is where the exciting stuff starts happening. So just to give you an idea, this is why I think it should be great. The actual API is fairly small. It's a couple of new endpoints that allow us to list files available in a package and to fetch those files individually by hash. It's kind of like unpackage, right? That's it. That's pretty much a new idea for the API. But what do we get from this? Well, for one, some analysis on our end estimates that it could involve up to 40% reduction in data transfer. That means your installs get a lot faster. They get done way faster. It means that if you're on a connection slower than fiber, you'll have less to wait for. You might actually finish your NPM install before the heat death of the universe. It also means you'll store less stuff on your system. You won't need to download READMEs, change logs, test code, anything like that. You only download the files that you actually use. So this reduction is mainly achieved by having Tink shell fetch files lazily. So you only download something when you first read it, and then we cache it really aggressively. This is one of the most exciting reasons to do Tink for me. Finally, this one's pretty interesting. Doing things like this has the potential to completely change how certain monorepo-based libraries work. For example, Lodash and Babel. As you probably already know, these libraries involve a lot of subtools, literally 147 packages in the Babel monorepo. So they just publish all of this under the scope so folks don't have to depend on the entire thing, right? You don't want to have the entirety of Babel. You want Babel core, you want maybe Babel CLI, maybe a handful of other things. Now, this can cause a lot of problems. For example, users can have issues keeping all packages in sync if they depend on each other in some way. On the package publisher side, this is a really fragile setup because it makes their publish process super prone to like publish errors or timeouts. And then they need to make sure they're able to restart the entire publishing process from where it failed. And it just gets nasty. So all of these tiny packages have to be released at the same time, usually all with the same version, and then you have to deal with the registry being eventually consistent. So not all package versions might be available when your user starts installing them, and there's just chaos everywhere, and it's awful, and NPM starts erroring on you, and no one likes that. With Tink and the new registry API, this wouldn't be necessary anymore. Lodash and Babel would be able to publish a single omnibus package, way more than most users would use, but when you install it with Tink, it'll only fetch the sub-packages you're actually using from within the big package. Everyone wins, and you only have to have one Lodash or Babel item in your package.json instead of 12 different things. Anyway, that's that. Like I said, this isn't in progress yet, but it's something we're planning on doing because the advantages are really clear to us all around. I hope you enjoy it when it does happen. In conclusion, Tink is exciting, and also it's kind of a work in progress. I'm sorry if you try and download it and it explodes in your face. Please keep away from flammable things. It works by having a virtual node modules that becomes your new runtime. It has TypeScript, ESM, JSX, and WASM support out of the box. It'll be known as NPM 8 when released, and we're going to have a new unpackaged style registry API in the future. So you can help make Tink happen. Join us. You can go to npm.community/c/development. You can check out the repo at npm/tink on GitHub. I am maybe_cats on Twitter and zcat on GitHub. Thank you. Nailed it.